Okay, let's have a look at some problem solving involving these linear equations. What we're really talking about are these worded problems. The worded problems are a little tricky in that, let's just do one. That would be the easiest way. Okay, so I've copied this one. Phoebe spends 2 hours training for an upcoming race. She runs full speed at 8 kilometers per hour for the race distance. Then she walks back to her starting point at 2 kilometers per hour. So how long does she spend walking? How long does she spend running? Okay, so there's kind of two questions we're being asked here. So question number one that we're looking at is this one. How long does she spend walking? Question number two really is, how long does she spend running? Okay, so we've got two things that we need to consider. Obviously we're looking at some sort of algebraic linear equation problem that we need to solve. So the place to start is to identify what the unknown quantity is and then represent it with some sort of pronumeral, some sort of variable. So what would be an appropriate thing to determine here for our unknown? What is our unknown? Well, we know that the total time that she spent running was 2 hours. We have that information up in here, in this area here. So we know that she was training for 2 hours. Okay. All right. There's some other important information. In fact, I might change that to a different color entirely. What do we know? Well, we know that her running speed was 8 kilometers an hour. That's the same sort of color as our question with the running. And we know that her walking speed is 2 kilometers an hour. That's in the same color as the walking information. So that's all the information that we're given. So I'm going to start with what she did first, the time that she spent running. So how long did she spend running? Well, we don't actually know. We're just going to call that Y. I could have called it X, could have called it F, whatever. What you call it, it doesn't really matter. It's your choice. So based on the fact that she was running for a Y period of time, we know that the time that she would have spent walking then is the 2 hours minus the running time, right? So it'll be 2 minus Y. Okay, so we've got some understanding. She spent Y minutes running, and she spent 2 hours minus Y walking. Okay, I think we're good with that so far. All right, let's have a look at what else do we need. Well, it's all about distance. Okay, so distance is what we're looking for. So the formula for distance is equal to your speed multiplied by your time. That's the formula for distance. You learn that in science. So we know that for running, her distance is equal to 8 kilometers per hour. That's her speed, multiplied by Y, which was her time. That's what we determined back up on this line here. Okay, so it's the 8 kilometers an hour multiplied by the time she spent running, which we said was Y. All right, for the walking, however, we have that her distance will be equal to the speed she was walking. We know that from the question, she was walking at 2 kilometers an hour, and it'll be multiplied by the time spent walking, which was 2 hours minus the Y. Now you'll notice that I don't have units on these numbers. They're not really important for what I'm doing right now. The unit at the end, however, that will be important. Okay, so we've got everything that we really need. We've got her distance for both, and it's really a question about time, but we'll get there. We'll get to the answer. I want you to see that in both of the equations that I have distance and distance being equal to something. So really, they're both equivalent, right? These ones are equivalent. So I can actually rewrite my formulas, my equations, my expressions into a linear equation. I have my running on the left-hand side, which is the distance, and it is equal to the distance of her walking. Okay, so this is the running and the walking. Okay, so now that I have constructed an algebraic equation, I can solve that. Okay, so I can multiply out the bracket on. I could have actually divided by 2 on both sides first, which would have made things easier, but I didn't. So we're going to multiply out this bracket, so it will become 8y is equal to 4 minus 2y. Very good. I'm going to then shift the minus 2y, because I've got y's on both sides and I don't really want that. So I'm going to take this 2y, this minus 2y, and shift it over to the other side by adding 2y to both sides. I'm going to have 10y is equal to 4. And then I want my y to be by itself, so I'm going to divide both sides by 4. And I'm going to figure out that my y value is equal to 0.4. So I need to remind myself, what was that y value? Well, my y value is the value or the time I spent running. So the Phoebe ran for 0.4 of an hour. I actually think it's probably better to talk in terms of minutes here. So I'm going to convert my 0.4 hours into 24 minutes. The time she spent walking then will be equal to 2 hours minus the time she spent running. So if she ran for 0.4 hours, she'll have actually walked for 1.6 hours. And when you convert 1.6 hours into minutes, it will be equal to 1 hour and 36 minutes. So because it's a worded problem, it's important to write your answer as a worded solution. And so you would say, Phoebe spends 24 minutes running and 1 hour and 36 minutes walking. Okay, we were asked a question with words. We need to answer with words. Of course, I'm not going to go through the checking, but you should check that this works for your calculations so that you know that you're right.